Python Paradigms. Introduction. Hi everyone. In this tutorial, we will learn about the two main Python paradigms, functional programming and object-oriented programming. We will learn about functions, classes, and methods. We will explore logical reasoning behind the reasons for use of these paradigms, and we will obtain hands-on practice using the Python programming language. This is an interesting and important topic in Python. I will try to make this session as informative as possible. This tutorial will teach us advanced Python skills. Let us begin. What is a function? A function in Python is a collection of statements that are grouped together and can be called together to do a specified purpose. All lines of code enclosed in a function serve a common purpose. Common purpose in the sense that logically speaking, all lines of code in a function will execute and work towards achieving a common output. The function has the ability to take an optional set of parameters or optionally return a value. What this means is that it is not compulsory for a function to have parameters, nor is it compulsory for a function to return a value, output. Just like a variable in Python, you must first define a function before you attempt to call and use it. Functions can be defined in one location and then called or invoked from another. This aids in making code more modular and understandable. A function after creation is like a large block of code in your script that you may call as many times as you would like to perform the same logic over and over again, but on different input. The general syntax for defining a function in Python is shown on the next slide. Define function name, parentheses, lines of code. Looking at the previous slide, we see the general syntax to create a function in Python. To create or define a function in Python, we need to make use of the def keyword, followed by the name of our function and a parenthesis, brackets. Thereafter a colon, and within the function we need to indent all lines of code that fall within this function. A function is essentially a name given to a group of code lines that work together to achieve a common output. Instead of calling each line separately, we can call them by their collective function name. So essentially, after creation, by calling this function, we are calling on the lines of code inside this function, and the lines of code within the function will be executed. We may call the function as many times as we would like for use after creation. Let us understand the logic behind functions with an example. I will create a simple function with the name hello world. This function will simply print the text hello world to our screen when called. Define hello world, print hello world. I should mention that there are not too many rules about how you should go about naming your function. Names can be in camel notation or even snake notation. The most important point to consider when naming your function is to have a name that relates to the logic that is implemented by it. For example, we would like our function to print the text hello world, and therefore we would name our function hello world, or maybe greeting function, or so on. The importance of calling a function. I would like to mention that when we define a function and run the script, it means that the function has been defined, created, and is available for us to use. However, if we would like to use the function that we have created, we need to call the function. For example, after creating our hello world function, we run our script. We will not see any output. The reason as to why we see no output is because yes, we have created the function, yes, we have the function available in our script, but in our current script, there is no instance in which we call the function. There is nowhere in our script that tells the function to execute at that point. So we proceed to call our function. Also, as we mentioned before, after creation you may call your function as many times as you would like. Define hello world, print hello world, hello world, hello world, hello world. The output hello world, hello world, hello world. Looking at the previous slide, we are able to see that I have called the hello world function 3 times, which resulted in the text hello world being printed 3 times. The manner in which you call a function depends on how you coded the function. You see, the hello world function we have coded does not have any parameters. It does not allow us to send input to it. I would like to show you another example. This time we shall create a function that adds 2 values. We would code it and call it as follows. Define addition function, print 5 plus 5, addition function. Looking above, we see that what we have coded is also simple. It is also very similar to the previous hello world function, only that now, instead of printing hello world to the screen, the addition function will print the sum of 5 plus 5, which is 10. Output is seen as follows. And output is as we expected. Now, from how we designed the addition function, it seems that this function will always print the value of 10 to the screen. And if we wanted to obtain the sum of another 2 different values, we would have to change it in the print function that is located inside the addition function just to get a different output. For example, if we wanted to know what is 10 plus 10, we would change it as follows. Define addition function, print 10 plus 10. Addition function 20. Looking at the previous slide, do you see what I mean? It is a bit inconvenient that we have to change the contents of the print statement just for us to obtain the sum of different values. You see, we are facing this issue because at the moment, there is no way for us to get input into our function. There are actually 2 convenient ways for us to get our function to accept input that is given by us and then add those values and print the sum of them. One way, as you may have guessed, would be for us to simply insert 2 input prompts inside the function. We do this using Python's inbuilt input function. It would be a relatively easy task, just like how we have been doing all this while, only now our code gets placed inside a function. We can easily create 2 variables representing the 2 input prompts that will store our 2 values, one each. And after that, we may print the sum of these values to our screen as follows. Define addition function num1 is equal to int input, please enter number 1. Num2 is equal to int input, please enter number 2. Print the sum of num1 and num2 is num1 plus num2. Addition function. Output to our new and improved addition function will show as follows. Please enter number 1, 50. Please enter number 2, 50. The sum of 50 and 50 is 100. Now, looking back at what we have seen about functions thus far, we are able to see how functions enable more powerful, sophisticated Python programs to be created. Before we see the second way in which we may pass input to our function, I would like to mention to you everything that we have learned about Python in previous tutorials, from decision making to comparison operators and loops. Every piece of syntax has the ability to be integrated into a function. I encourage you to play around with functions using the knowledge we have learned about loops and input and decision making in Python. Integrate these into simple 10 to 20 lines functions to see how the creation and calling of a function work. We shall now look at the second way in which a function will allow us to send input into it to use for processing. An introduction to function parameters. As we know, functions have the ability to have what we call parameters, and these parameters take arguments. A parameter is like a variable that accepts the values we pass to them. The value that we pass a parameter is referred to as an argument. Therefore, parameters are like variables that have been integrated into a function, and they allow us to provide values to them in the form of arguments, and these arguments can be processed by the function in various ways, very similar to how we have been processing variables in Python all along. The general syntax of a function with parameters. The syntax of a function with parameters does not differ greatly. Below is the general syntax of a function with parameters. Define function, parameter 1, parameter 2, parameter n, lines of code. A function in Python may have an unlimited number of parameters. Reconstructing our addition function, below is the syntax for the addition function, but this time we code our function with the two parameters, namely num1 and num2. Define addition function num1, num2. Print the sum of num1 and num2 is num1 plus num2. Notice we use the def keyword followed by the function name and a pair of parentheses. However, when a function with parameters, variables, is created, we need to put all the parameters, the names of the parameters that the function has, inside the parentheses. Each parameter needs to be separated from the next using a comma. Looking at the above syntax of our addition function, we are able to see immediately that the use of parameters enables us to have neater and shorter code blocks. Now, let's think logically. When we created a function with no parameters, the way in which we called the function was with an empty parenthesis. This is because our function with no parameters was obtaining input inside the function using an input prompt. However, in our function with parameters, there are no input prompts inside the function to collect input for num1 and num2 values. But our function with parameters has parameters, and parameters are variables that enable us to pass arguments to them, and these arguments are able to be processed inside the function, allowing us to execute logic and manipulate the arguments passed to parameters. Therefore, when calling a function with parameters, you will not call the function with an empty parenthesis. You will call the function while passing arguments for all compulsory parameters. Look at the example of calling our addition function with arguments that have been passed for the parameters num1 and num2. Remember, once defined, you may call and use your function as many times as you like. Output will be seen as follows. The sum of 50 and 50 is 100. The sum of 100 and 100 is 200. Look back a few slides and notice how we called the addition function with parameters. First, we call the addition function by specifying the name of the parameter and then setting it equal to an argument, just like a variable. On the second call, we omitted the parameter names and simply passed two values to the function. This is the point when I should mention to you that a sequence of parameters in a function and arguments passed to it are respective. In other words, when we call the addition function the second time, the reason there was no need for us to specify the name of the parameter and the value it was equal to is because we defined the addition function with two parameters in the order num1 and num2. And by calling the addition function with the values 50 and 50, the Python interpreter already knew that the first 50 we passed as an argument would be assigned to num1 and the second 50 we passed would be assigned to num2. Again, because the parameters given upon definition and the arguments passed upon calling are respective. The first argument will be assigned to the first parameter, second argument to the second parameter, and so on. I would say that specifying the name of the parameter and the value that it is equal to is not something that we have to do all the time, but one will find that by going the extra mile to code the parameter name, one improves their level of comfort with the function in Python. Also, we will see that there are certain times when specifying the name of the parameter is useful. A doc string. This applies to all functions. As you know, we have seen the general syntax for a function with and a function without parameters. This is excellent. We are doing very well with our journey of Python together. Now, this new feature, I would call it, is one that applies to all functions. You see, it is called a docstring, and it is nothing too difficult. In the real world, programmers very rarely tackle a project solo. Even if it is done solo, there would most likely be a code check or verification that will be done by a team supervisor or programmer. In this case, if the program script has a lot of functions that have been defined in it, it would be difficult for another programmer to figure out what each function does. Maybe the programmer would need to rely on the name given to the function to figure out what the function does or purpose it serves in the code's logic. However, it would be very time consuming and inconvenient for the programmer to do this. That is why, to make it easier for programmers to understand the logic behind functions when defining the function, we have the ability to add what is called a docstring to the function. A docstring is a string text that simply describes the logic integrated into the function. The docstring tells us what the function does. A docstring is optional and it will appear below the function name, usually as the first line of code inside the function. An example of a function with an added docstring is shown on the next slide. Define addition function num1 num2. A docstring tells us what the function does. The addition function will add two values together. Print the sum of num1 and num2 is num1 plus num2. Addition function num1 is equal to 50, num2 is equal to 50. Addition function 100, 100. Looking at the docstring on the previous slide, we are able to see that our docstring appears below the function name. It is called a docstring. Therefore, we use quotation marks to denote it in a function. It is good to know that the reason why we use three pairs of quotation marks is because using triple quotations will allow our docstring to cover multiple lines. Like in our case, we see that we were able to make our docstring span two lines. If single or double quotations were used, our docstring would only be a one-liner. Therefore, we would have to place all our docstring text inside this one-liner. It would work, but it won't be as neat as triple quotations. I recommend that you always use triple quotations for your documentation string, docstring. It will allow your documentation string to cover multiple lines. Program control flow with functions. We have spoken about what a function is, and we have also looked at a few examples of functions in Python. Now we will look at how a function affects the way in which our program flows during execution and interpretation. That is, we will look at program control flow with respect to functions. You see, in Python, when a function is called or invoked, the control of the program will jump from the point where the function was called to the point where the function was defined. This is why we need to define and create a function before we call or invoke it. When control flow jumps to the point where the function was created, the body of the function, code lines within the function, is executed, and then program control flow will return back to where the function was called from. Execution and interpretation of our script will then continue. I will give you an example that shows how a function behaves and affects program control flow. Print, this statement encountered first. Print, main program has control. Print, creating function. Define program control flow. Print, control given to function. Print, now in body of function. Print, code inside function executing. Print, calling function next. Program control flow. Print, control passed back to main program. Print, outside function. Print, main program terminated. When we execute the program on the previous slide, we are shown output as follows. This statement encountered first, main program has control, creating function, calling function next, control given to function, now in body of function, code inside function executing, control passed back to main program, outside function, main program terminated. My apologies if the output is a bit too long a paragraph to read. I would like all students watching this tutorial to understand these concepts to the best of their potential. Look at the order in which the output shows and look at the order of our code. Essentially what happens is this. Our Python script is run, executed, the entire script gets compiled. One important point to note during the compilation stage is that all variables and functions that are created are given their own space in our system memory, RAM, and are available for us to use if needs be. Remember, Python executes a script from left to right, top to bottom. So after compilation occurs, interpretation of our program begins. First, the interpreter will encounter the first line of code that prints this statement encountered first. Then the second line of code executes and we see the message main program has control. This tells us that the interpreter is still executing code from the main program. Afterwards, we see the text creating function. This is the third line of output in our console. The next line of output, fourth line, is calling function next. Now you may have a question. In our code, the function is seen before the statement calling function next. What I mean is define program control flow, print control given to function, print now in body of function, print code inside function executing. The above lines of code are shown before print calling function next, the above line of code. So why in our output it shows as calling function next, control given to function, now in body of function, code inside function executing. The question is, why not execute the function first and then get to the print statement which says calling function next? The answer is simple. It is as we have discussed all along. To use a function, you have to call a function. And when the below lines of code was encountered by the interpreter, define program control flow, print control given to function, print now in body of function, print code inside function executing, the interpreter could not produce output from anything because the above lines of code, was simply us creating the function, not calling the function. Therefore, during the compilation process, this function was given a spot in our computer RAM to live in for the duration of program execution. So, since there was nothing for the interpreter to do with the definition of the function during the script interpretation, it moved on to the below line of code, print calling function next. This accounts for the fourth line of output in the console, calling function next. So after calling function next, we see that the next lines of output are those that we coded in the function. This means that after print calling function next, the above line of code was executed, the interpreter moved on to the next line of code, which was program control flow. Hence, now we see that our interpreter encountered a line of code in which a function was called, and this function happened to have been compiled and resides in our RAM. By the interpreter stumbling along our function call program control flow, the interpreter jumps to the point at which the function was defined in our script. This is possible because of RAM. Our RAM was storing the function and its contents. Therefore, the interpreter will now execute all code inside the function line by line. This accounts for the output we see in our console. Control given to function, now in body of function, code inside function executing. After the contents of the function was executed and the interpreter had no more lines of code inside the function to execute, we see in our program that the next line encountered was control passed back to main program. This tells us that after the call of the function was executed, the contents of the function was executed. After the last line of code inside the function was executed, our program control was passed back to the main program, which means execution continues from the point at which the function was called onwards. This means the below lines of code were executed. Print, control passed back to main program, print outside function, print main program terminated. And this accounts for the remaining lines of output that we see in our IPython console. Control passed back to main program, outside function, main program terminated. I do hope that this makes sense to you. To ensure that you have a full understanding of the way in which a function affects program control flow, I would like to give you two simple diagrams of steps shown on the next slide. It is our code script with comments and flow arrows that show how the script execute and the order in which the events occur. First, second, third, fifth, sixth, seventh, fourth, go to function and execute code, eighth, ninth, 10th. Number 1, print this statement encountered first. Number 2, print main program has control. Number 3, print creating function. Function compiled, no interpretation. Number 4, print calling function next. Function called all the way back up. Control given to our function. Function was called, therefore function will execute. Number 5, print control given to function. Number 6, print now in body of function. Number 7, at the end of function, control given to where the function was called. Number 8, print control passed back to main program. Number 9, print outside function. Number 10, print main program terminated. Excellent. I hope that you understand the logic behind program control flow better. Now, you see, one last point I should mention about control flow with regards to functions is that, remember, we have the ability to call a function an infinite number of times after definition of the function. Therefore, each time a call is made to program control flow function, the program control flow will jump from the point of calling to the point of definition, and the statements within the body of the function will be executed. Upon reaching the end of the code inside the function body, program control flow will be returned to just below the point at which the function was called, and the execution of the remaining Python script will continue.